If you're like me, you take clean drinking water for granted. All my life, professionally treated, safely managed, potable drinking water has always been a faucet or drinking fountain away. But I recognize not everyone is so fortunate. An estimated 2 billion people worldwide don't have access to clean drinking water. And when I say that, you probably imagine this affecting people in developing nations, or maybe conflict zones. So it might come as a surprise to learn that an estimated 12% of people in the United States live without reliable access to clean drinking water. Today's guest, Lee Voth Gaeddert, is exploring ways to treat this gap in water treatment. He's an engineer and a researcher in the Biodesign Center for Health Through Microbiomes, looking to solve global challenges in water, sanitation, and food security. From Arizona State University, this is Lab Coat Optional, the show where advanced research meets everyday curiosity. I'm your host, Pete Zaroka. In each episode, we dive into the latest research shaping our world, minus the jargon, and definitely minus the lab coat. In this episode, Lee and I cover more than just drinking water. We examine the drug-resistant microbes permeating our environment and novel ways we can leverage our own microbiome to treat chronic child malnutrition. It's a far-ranging conversation that might change the way you look at the invisible systems that keep us all healthy, and maybe spur ideas on how to improve them. Lee, welcome to the show.
Thanks for having me.
I'm so excited. Okay, so my first question is maybe a doozy, but it involves your academic trajectory.
Okay.
So your undergraduate and postgraduate degrees are in civil and environmental engineering. Mm-hmm. And then you went into global health engineering and pediatrics and child health. Is there like a disciplinary through line there or a singular problem or kind of challenge you're looking to solve? Because from a layman's perspective, it seems like there's some turns there.
Yeah, I think that's a fair assessment.
Okay.
But so I'm very problem driven, and I've always been relatively passionate, and now even more passionate about child health in general. I think kind of about fundamental needs, so water and food, security, those types of things.
Important.
And so I think about, okay, where do we get the water from? So I was really kind of focused on how do you move water from A to B, civil engineering.
Yeah.
And then I was like, well, yeah, we need to be able to move water from A to B, but we need to make sure it's clean when it gets there.
Okay.
So then I was like, okay, let's think about environmental engineering. So I got my environmental engineering degree, a master's degree at that point, so I could learn about how to clean water. But then I was like, okay, got there, and it's clean, but the kids are still sick. Why is that? And so then I got a little more into kind of, pediatric space. I'm not a pediatrician by any means. I'm an engineer. I kind of stick with that and work with people who are way smarter than I am. But that was kind of my trajectory of actually getting to, trying to understand the kind of multimodal problem that kids face oftentimes, especially in lower resource settings and those types of scenarios.
It's an onion. You kept pulling back layers to try and get to the
I should
core
stop
of the
at some
problem.
point,
Yeah, maybe you will become like a pediatrician to really try and figure it out. So the first thing I want to talk about is your work with water security.
Yeah.
You and your colleagues published a paper somewhat recently, and it estimated about 12% of Americans don't have access to a reliable, clean water source. Where are these people, and how does this happen in an industrialized, developed country in 2025?
Yeah. So from a global perspective, the World Health Organization and the United Nations at large have something called the Sustainable Development Goals.
Yeah.
There's a couple around water and sanitation. And so everyone has to, even the high-income countries, have to report metrics to the UN to kind of say where we're at. Oftentimes when we do that, we use certain metrics that only capture part of the population. We don't actually realize it. So if you're not on on like a municipal water system, sometimes you don't get reported as having access to water or not. You're excluded from that number.
Interesting.
And so if you are excluded from the number, it kind of like skews the number a little bit. And so what we typically report to like the UN from the US perspective is oftentimes a little bit higher than reality. So whether it's unhoused populations or it's folks, in the Navajo Nation or Native Alaskan communities, or folks in kind of the rural South, rural, Arizona, there's all these different populations that are not on centralized systems, trying to make do, get by.
And to put a fine point on it, if you're not on a municipal water system, you're getting your water from what, a well?
Yeah, so wells are most common. I grew up on a well.
Okay.
Rural Kansas is kind of where I grew up.
Yeah.
So a lot of folks around me also had well water. And we were lucky because we had an aquifer right beneath us in Kansas, the Ogallala Aquifer, if I pronounced
Very
that right.
familiar with it, yeah.
yeah. As most people
Everyone
are.
knows that one. The best aquifer.
But so it wasn't hard to drill and hit water and have it sustainably. And even if your neighbor was pumping a lot of water, you weren't going to be affected. So a lot of people are on wells. But a lot of people actually haul their own water too, especially if they can't drill, especially around here.
Yeah.
If you can't drill 1,000 feet deep, you can't pay for that kind of well because that's $50,000 at least.
Yep.
So it's expensive to do that. So you might be hauling water yourself. You might pay a company to haul water. Or we've done a lot of work in the U.S. Virgin Islands. So one of the territories in the southeast, kind of near east of Puerto Rico.
Sure.
Most of them, they do rain harvest capture.
Yeah.
So it's really quite fascinating. They capture it, they put it into, they literally pour a basement foundation and fill it up with water. It's 5,000 gallons worth of water in terms of the size that they can contain.
They have basement swimming pools?
Essentially, you don't want to go in there.
You don't want to go in it.
You don't want to go in there, but essentially that's what it is. And they have a pump and a pressure tank, and that's how they get water kind of to the house. But in terms of thinking about the water systems that people are, where people are getting water, that rain harvesting is another pretty common one in certain pockets of the U.S.
Sure.
Virgin Islands being one of them.
Okay, interesting. So, all right, people with wells, people with basement swimming pools.
Yep.
People trucking in their water.
Yep.
What kind of challenges do they face?
The big things that we highlight in that paper are really the fact that if you don't have a municipal system, the municipal system is really nice because I just turn the tap on and I pay a fee.
Yep.
That's really, an issue happens, I call someone, or if something happens with the water system, I get notified. It's pretty systematic in terms of all those things. And there's a professional that's been trained that's in charge of the water system. When you're doing your own thing, wells or rain harvesting or hauling your own water, you're managing a lot of that kind of system from water source to consumption.
And it takes a level of technical expertise.
Yeah, and so you might be hiring a plumber every once in a while, or you might have a water hauling person come in or something like that. So there's also a lot more of stakeholders involved oftentimes, or you're just on your own.
Right.
And so it's all right, if you're on your own, how do you manage that, especially if you're not a trained, water expert?
Sure.
I forget to change my own water filters at home, sometimes, and I'm like, oh man, I should have changed that a long time ago.
Yeah, I've been
so
there.
so you're doing water management, sourcing your water, treating your water, and so, water storage management. So there's a lot of things that go into that. So it's all right, how do we kind of systematically go through all those things, map them out in terms of the challenges each of those components, kind of bring to the table, and then figure out ways to different levels of engagement for households.
And that level of individualized control, or not control, but responsibility.
Yeah, responsibility. I think is a great word.
Speaks to the title of the paper, which was "When the Home is the Utility."
Yeah.
Right. But big thrust of the paper was you developed a model for collaboration to tackle these different challenges. Can you walk me through that?
Yeah, I'll try, because it's tough because of the variety of situations that we find these households in.
Yeah.
And so what we try and do there is really frame the idea of there's kind of these staple stakeholders. There's always going to be some level of policymaker that's involved. There's always going to be some level, there's going to be a household involved, and there's probably going to be a couple of other stakeholders involved as well. So we're kind of we try and frame it that way of there's going to be these kind of cross-cutting people involved in these systems and infrastructure that's going to be involved.
Right.
With that, where do we go from here? What are your options? If you want to go it alone or primarily take on the responsibility as a household, here's a set of options that you have in terms of information to make decisions, types of treatment systems you can use, things to be aware of if you're managing your own well. So we try to kind of take that framing for households. The other kind of thing that we're trying to push, and something I am very interested in having the experiences I do, is how do we think about service models? Can I just be a household that pays someone to come take care of all this for me?
Right.
Because we have that. That's what the municipal system does.
Yeah.
And if I'm paying someone to haul water, they're hauling this valuable product to me, and so I'm paying for a product. Can I do the same thing with someone who comes to change my filters, to make sure my pump's running appropriately, those types of things? It's trickier from a kind of economics perspective.
Sure.
But having more research in that space is critical.
I was curious about 12%. as 12% of people in the United States are water insecure. Do you think climate stressors like droughts or floods are going to exacerbate this as we look to the future?
Yeah, I mean, I think they already are. I think there is certainly, if you are dependent on rain harvesting in terms of your source, that's a key piece of it. If you're doing kind of management at the household level, there are certain stressors that might kind of increase that. Certainly water use, if you're using that dual use water for, a lot of times people use that water both for domestic, but also either gardening or animal rearing, raising whatever kind of livestock they might have as well. And so that, obviously puts stressors on, where that water is coming from. And also, if water is scarce, oftentimes the price of water goes up to match that. And so then it becomes an economic issue as well. Even that kind of like climate adaptation is very important kind of in this space, and building the systems that kind of can sustain those shocks, I think, is something that we're getting better at, but we got a long ways to go.
Yeah. So what is next for this research? How are you distributing this kind of collaborative model that we talked about, where you're bringing in stakeholders and municipalities, et cetera?
Yeah, so it's a multi-pronged approach in a lot of ways. So we're kind of really treating it as almost, for lack of a better term, a checklist of like, okay, do we have the information we need to make the recommendations or decisions we do in certain kind of domains? So water storage in the Virgin Islands, Navajo, and rural, Arizona. What recommendations do we have? What are typical practices? Do we have the right ones that are data backed? And we just go through the checklist to make sure we have all that information. And that's really kind of on the applied research side. That's kind of what we're thinking about.
Sure.
But then it's, to your point, it's then engaging with and making sure that we have robust collaborations with municipal systems, if they're thinking about taking responsibility on for decentralized systems, which that's actually becoming a more and more of a topic. If you have failing infrastructure, it's actually probably to some degree cheaper to send water filters to some of your systems to make sure that they hit compliance than it is to you go pull up a whole street worth of piping and replace that pipe. So there's different things that municipal systems are thinking about, which, for better or worse, we can kind of debate the effectiveness of those approaches, but it kind of brings to bear a lot of the potential solutions that we have at our fingertips in terms of addressing some of these challenges. So
okay, cool. All right, so water access is one thing, but you've also done work about stuff in the water. You did some work with drug-resistant bacteria in wastewater. Can you tell me a little bit about that?
Yeah, that's a fun one. So that one, we're really interested in, and maybe a lot of people have heard about antibiotic resistance.
Sure.
So antibiotic resistance, if you're not familiar with, is just the fact that, there's microbes everywhere, right? And certain microbes make us sick. And some of those microbes, when we get sick, we might take an antibiotic to kill those microbes. But sometimes, and specifically bacteria, I should say. So antibiotics, bacteria, antivirals, viruses.
Different things.
Different things. Make sure you know what you're getting and doing it appropriately. But so these bacteria that you might get, let's say you get like 100 bacteria in you, and you take an antibiotic because those bacteria are pathogens, they're making you sick. It kills 95 of them. You start feeling better. Good. Awesome.
Pretty good rate of effectiveness.
But you still have about 5 of them in you.
Oh, okay.
And you stop taking your antibiotics. So this thing that's, getting rid of the pathogen has now like disappeared. And then these 5 that might be just a little bit more resistant to the antibiotic proliferate more and more. It might not make you sick again, but you're going to put them into the environment and flushing your toilet, and then the treatment plant might remove some of them, but it gets in the environment. And so that's kind of how this antibiotic resistance spreads more and more. Okay. And there's different types of bacteria that are resistant to different types of antibiotics, and so it's complicated, but there are systematic approaches that we can do to kind of address it.
Okay, and this was in Indonesia, right?
Yeah, so this specific work is in Indonesia. The kind of framework we work under is something called the One Health framework.
Okay.
So that's the environment, animals, and humans.
Sure.
We're all connected, right?
Yeah.
There's all these systems, interconnected systems.
Yep.
And what we think about really is we think about human health, animal health, and then the environment that kind of brings these systems together. And so in Indonesia, we were looking specifically at chicken slaughterhouses.
Okay.
So it was fascinating. We got tours of the chicken slaughterhouses to see the whole process, and then they offered us chicken nuggets at the end. Little less tasty after seeing how they're made.
I think so.
I love chicken nuggets, but not after that. So that was fun. But getting to see that process, and the whole goal of a chicken slaughterhouse is to, take your animal, so it's coming in from the environment, which has whatever in it, and you bring the animal in, and then you're trying to separate the tasty chicken nuggets from the nasty part of the animal, and then the chicken nuggets go off to the humans, and so you have that connection of like animal to human. You have the connection of like animal to the environment, because that waste then hopefully is somewhat treated and then goes to the environment. And so it's like chicken slaughterhouses are a really interesting point to be able to monitor and to hopefully control some of the nastiness that is in these systems or that gets aggregated in these systems, one being antibiotic resistant pathogens.
So the chickens are treated with antibiotics, and that's how the antibiotics are getting in.
That's a great question. To a degree, and historically they have been. We're phasing that out. There's a big kind of push to traditionally we've used antibiotics because they actually really help animals grow quickly. Which is great for farming and for having high yields in terms of meat production and things like that. Not so great for spreading antibiotic resistance. So in the U.S. and other places, we've kind of phased out, especially using important antibiotics for humans in animals to make them grow. We don't allow that anymore. So they're more
effective for us.
Exactly. Yeah. But there is just antibiotic, resistance in the environment, both naturally and because of our usage of it. And so that's oftentimes how it might get into the chicken.
Sure.
And then, it might be like in the intestine of the chicken. And oftentimes, at least in the U.S., we don't eat the intestinal part of the chicken. So that's the waste part. And so, all right, in the waste, how do we deal with that? How do we kind of ensure that the waste streams are kind of mitigated in terms of, the nastiness that's in there?
Right. Okay. So, and it's not, so antibiotic, as you're saying, antibiotic resistant bacteria don't just form because, a chicken slaughterhouse. It's happening every time we use the potty. I have a 3-year-old. Sorry. That's embarrassing. The toilet every time we use the bathroom.
I have a 3-year-old and a 9-month-old. So
okay, so you get it. Have you used potty in a professional context before?
All the time.
All right, cool.
All the time.
We could retake that, but it's fine.
I love it.
So some of the water that you tested coming out of these chicken slaughterhouses did go through wastewater treatment plants,
correct,
right?
Yeah.
What kind of difference do you notice between the wastewater treatment and the stuff that ending up in water sources?
Yeah, so if they have good treatment, the total abundance of the microbes that are carrying this resistance is way less.
Yeah, okay.
Which is our goal, right?
Yeah,
as an engineer, I'm like, great job. You're doing great. But it's to some degree costly to run a treatment plant, especially if your main goal is to make chicken nuggets for us. The last thing you're thinking about is treating water, right?
Yeah.
But oftentimes it's enforced by regulation or something. So Indonesia has the same thing the U.S. has in terms of regulations of disposing water into the environment.
Okay.
It's easier to do when you're a larger corporation versus like a mom and pop company.
Sure.
And so typically the smaller slaughterhouses have kind of less effective treatment oftentimes. Again, the specific study we did, it was a small sample size, but by and large, it's kind of what we typically see. So the question becomes, if we really want to enforce regulation to help mitigate the spread of these things that isn't a direct benefit to the company's bottom line, how do we make it least burdensome?
Okay, cool. So recently you started a project to address malnutrition in children in Guatemala and South Africa, but it started by looking at fungal toxins in corn. So can you take me through that?
Yeah, so that's why I go back to my career has not been a straight path.
Yeah, not at all.
So again, I'm interested in goals as opposed to research domains, which maybe puts me a little bit different than some of my colleagues. God bless them because they're experts in their domain, and I would not be where I'm at without their help and collaboration. So that's what makes it fun.
Yeah.
But so on the corn side, this really kind of came about from some of the initial. We were doing water work. Again, we're kind of working with water systems in rural Guatemala.
Sure.
At the time, and we were kind of looking at water and sanitation systems and how people operated, and then we were kind of asking around both local NGOs and USAID was working there at the time, and they were like, well, you should really look at the corn. And we're like, the corn? Like, it's tasty, but what should I be looking for? Okay. And they're like, well, there's a toxin. I'm like, oh, okay, well, maybe I should have known that before I ate it, but it's fine. They were really interested in one specific called aflatoxin. It's a type of mycotoxin, which essentially is this thing that's produced by a certain fungi. one, it causes major headaches in terms of food safety, and it causes a lot of detrimental issues in terms of human populations that are exposed to it.
Okay.
So USDA does a pretty good job of regulating it in the US and weeding it out. It goes to the grain silo, and there's kind of initial screening there. It goes to the food processing plant before it even gets there. It's screened to a different level. And so we've developed kind of different ways to screen for this specific fungal toxin. But in agrarian societies or parts of the economies in lower kind of resource settings that use more kind of decentralized agricultural models. Like ours is very centralized, right? We got like big farms, we got a big kind of co-ops in terms of where the ag goes, in these kind of more decentralized spaces where, a specific farmer might take their, grain right to the market and sell it in the market themselves, as opposed to doing like a mini co-op or something. It's a lot harder to monitor these types of toxins.
They don't have the same kind of robust system to look at it.
It all goes back to these monitoring systems. Full circle. But so that's what we're interested in terms of understanding the implications of having kind of high levels of this toxin in your food supply. Because we already know, like since the 70s, we knew aflatoxin, this fungal toxin, was a class 1 carcinogen. But there's other potential implications. If it causes issues there, it probably causes other issues other way, especially if you're a child.
Yeah.
And if you're trying to just get by in terms of food consumption and getting enough calories to survive. There's a lot of potential implications for that exposure, and we're trying to kind of figure out what those implications are.
Okay, and so potentially, what are some of the implications?
There's implications to kind of inflaming the gut, essentially, and then inflaming the whole body. If the gut's inflamed, it's going to get into the body. It's calling inflammation is not a good thing in general, right? And especially if you're a child trying to grow and survive, like not a good thing. And so there's implications for what that does in terms of just your function as your body's functioning, but also like your body's trying to grow as a kid, right?
Yeah.
Like I have a 9-month-old and a 3-year-old, so like they're trying to grow right now, and I'm trying to do the best I can to get them to grow, and that means good food and minimize the exposures to some degree.
Yeah.
I have chickens in the backyard to,
they're probably doing
a little
great.
Bit exposure,
yeah. So if you're inflamed all the time, that's going to have an effect in terms of malnutrition because you're going to not grow as you should be because your body's always fighting something.
Exactly. Yeah. So even if I'm consuming the right amount of calories and the right amount of nutrients, which are two different things, right?
Totally.
We can get enough calories, but not enough nutrients, not enough calories. So
hold on.
mind blowing, I know. But we need both those, and they're tricky sometimes because sometimes we get enough calories and we don't realize we're not getting enough nutrients. So that nutrient gap is critical, especially in that early kind of phase of development. So our body will take whatever nutrients we have, allocate it to the immune system to respond in terms of the inflammation that's going on. Yep. So, the function of the immune system eats up a lot of the things that should be going to growing our muscles and our organs and all the other things that are growing at that time, our brain. So that's one thing. And then another thing too is if your gut's inflamed, the gut is like the entryway to your body. Like, you might put it in your mouth, but technically it's not really in your actual guts and guts, your the rest of your goopy body, again, engineer.
Yeah.
But so where it actually enters in your body is in your small and large intestine, right? So the food gets down there and finally gets absorbed into the bloodstream and then goes and does its stuff.
Okay.
So that entryway is really fascinating because there's a lot of microbes in there that help with things like that can potentially help fight infections. Because the microbes, we have like a good relationship with a lot of the microbes in our gut, right?
Yeah, they're great down there. They're doing lots of stuff for us.
Exactly.
Yeah.
But you might get a bad one in there every once in a while that gives you diarrhea or something like that. And so your body will fight it. And also the other microbes in there, they're like, hey, I was enjoying myself. Why'd you come in here and do this? So they're also going to do, potentially help out a little bit as well. And so all that to say, there's a lot that goes on in your gut. And when you have this kind of toxin that comes in there, which is different than a microbe, it causes different issues, but it can still cause inflammation that causes your intestines to be less good at absorbing the nutrients that are going through your intestinal tract.
Sure.
And so you're just less good at taking and converting good food you've eaten into actual useful things your body can use. So it has knock-on effect. There's multiple ways that you can, your body can really suffer from this toxin and from pathogens in general, pathogen spaces.
Well, it's so kids have inflammation in their bodies. They're not getting the nutrients they need because their bodies are occupied trying to fight this toxin.
Yep.
what is your proposed like solution for it? What are you guys working on?
Yeah. So this goes to the title of our research center was the Center for Health Through Microbiomes.
Yep.
So there's kind of a hint of where we're focused at. So that microbiome that's sitting there does a lot of good for our body. It can. And we can even improve the efficiency of it in terms of the benefits it can provide. So there's a number of different ways that the microbiome really kind of plays a critical role in actually being able to either kind of help generally kind of mitigate the effects of like a toxin or a pathogen, but also maximize the benefit of food that we're eating.
Yeah.
So the way we can manipulate our microbiome are the best way is the diet, like our natural diet, right?
Yeah.
Like if we eat healthy, we eat a diversified diet, we usually have a diversified microbiome, and typically diversified microbiomes are better for you in terms of health and resilience to infections and things like that. So the more we can do to improve our diet, awesome.
Okay.
We can also be kind of targeted in how we do that. And this is where kind of, targeted nutrition or targeted therapeutics is kind of a whole, say new field. It's, 10, 15 years old, but people get really excited about kind of like individual targeted therapeutics. So this is another area we're thinking about of like, okay, if I want to work in rural Guatemala and provide a solution there, I don't think it's tricky in terms of building a solution like a probiotic. So a probiotic, you think of like yogurt, for example, right? But we can actually have like little probiotics in a pill, or even like a full-on microbiome transplant is a thing. So you can
is that like a fecal transplant?
Yeah, it's like a poop in a pill.
Okay, cool.
Yeah. So and it might sound weird, but
it's sanitized poop in a pill.
Exactly.
Right?
Yeah. But it's shown in terms of different types of diseases to be quite effective at helping us kind of minimize some of the symptoms that we're having. All this kind of good stuff. So you can do that. You can do poop in a pill. You can do just kind of normal probiotic, which is quite common on the market. Here, trickier to do in kind of rural, low resource spaces in terms of access, but having just a food-based therapeutic, so combinations of foods that are built in a specific way to maximize or to help fight a specific thing that a population is facing, can be an effective strategy. So that's really what we're trying to kind of focus on right now.
So is there something proprietary in this food treatment you're talking about? Like your engineer, is there like a microbe like kind of embedded in it, or are you just talking about like a superfood smoothie or something?
Yeah, so somewhere in between there. That's
okay,
kind of
got
what
it.
So nothing proprietary, at least not right now.
Right.
And it's really just a combination of different types of foods, which the goal actually, and so people have done something where we do have like therapeutics you can go buy where you can eat them. We have this a lot for like acute malnutrition. So acute malnutrition is where you have kids that are the pictures are like famines that are just horrible to kind of see. You can see the bones through the kid's skin. Like they need calories now, and that's like a caloric problem.
Right.
There's a nutrient side of that, but they just need calories or they're going to die.
Yeah.
And so we have like food-based therapeutics that the goal is to get them high density, high caloric kind of intake as soon as possible. So we've engineered kind of food products to be able to do that effectively and to do it in a healthy way, because there's healthy ways to do it and non-healthy ways to do it on the kind of weight gain side of things.
Yeah.
On the chronic malnutrition side of things, it's a lot more complicated because we're now not just focused on weight, but we're just focused on like gut health. We're focused on nutrient absorption. We're focused, all the things, right? And so we're really kind of focused on, okay, how do we kind of take the model that people have developed for developing these therapeutics for weight gain and really think about it more holistically from a food and optimization perspective in the chronic malnutrition space. So that's our goal, is to get the gut ready to use the nutrients, and by getting the gut ready to use the nutrients, we're hoping that we can impact other body systems to be ready to use the nutrients as well, because you've heard of the gut-brain axis. There's the gut-liver axis, gut-kidney axis. There's all these axes now, but there's all like these connections that we're now learning more and more about, and so we're really trying to kind of leverage that and think of the gut as kind of that central node to all those systems.
I mean, it highlights how important what you eat really is.
Absolutely.
So how scalable is the solution you're talking about? Because you're looking primarily at Guatemala, right? But also there's a South African aspect to it as well. And I imagine those populations have different challenges and are just fundamentally different.
Different microbiomes, no, absolutely. So the reason Guatemala is so interesting is their rates of chronic malnutrition are close to 50%. Like 50% of kids have chronic malnutrition. And maybe I should define chronic malnutrition.
Yeah, please.
It's essentially, and it's not a great definition, and that's part of our qualm, but essentially we measure your height and compare it to where you should be at based on your age.
Okay.
And so if you are significantly shorter than where you should be at based on kind of how everyone else in the world grows.
Where you should be at on a global average?
Exactly.
Okay.
We have this kind of chronic malnutrition problem where 50% of the kids are in the 2.3rd percentile or below. So like they're almost, most of them are born halfway stunted.
Oh.
So it's obviously it's kind of multi-generational problem.
Yeah.
And so there's a lot of factors kind of in that space, thinking about prenatal health and all that good stuff. And so we're thinking about that as well. But if you're already born and you're growing, how do we help you catch up, essentially? Like if you're going along your normal trajectory or your like trajectory that's really low, how do we get you to have a little growth spurt, let's say? And so we can identify some kids that naturally do this for whatever reason, and we can kind of see what's going on in their body when that's happening. And how do we trigger that in kids that actually need it, or that other kids that need it as well, let's say. So that's kind of our approach to we have 3 or 4 different cohorts of kids we're following in Guatemala to really try and characterize and understand what actually helps kids have that growth spurt that gets them back onto like a healthy trajectory.
That's so cool. When I first tried to get you to come on our weird little show, you were talking about there's other leverage points to help childhood malnutrition and development. What are the leverage points people are currently focused on, and where else do you think that there's room to kind of figure this stuff out? Because water's a big one. We've talked about water.
Yeah.
Nutrition in general is a big one, but like, what about food systems? Like, what about social support in general?
Yeah.
Like, this is a very complicated problem.
Yeah, and I mean another one to throw in there is like stress. Like stress in your childhood is very detrimental as well.
Yeah.
So how do you create these safe environments for kids to grow, in healthy ways is critical. I hate to say it, but it's all context dependent, right?
Sure.
And so that's why, like, as an engineer, I love scalable solutions. Like, how do we think about scalable solutions? But if it's context dependent, it's that trade-off of like, we want to design something that's scalable yet locally adaptable. And so, understanding the fact that it's a multimodal problem, there's different prongs to it in terms of, the environmental exposures that you have, all the way to the stressors that you have, to the toxins in your food, to the diet that you have. And so part of what we're trying to do is appreciate the key leverage points that we have. And so the idea, similar to kind of why we were interested in a chicken slaughterhouse, you have all these different complicated systems that seem to all coalesce or intersect at certain points in those systems. So chicken slaughterhouses, have the animals, the food that connects to humans, to the environment. Nice central node to think about some type of control point there. And so I kind of worked in the water space for a while, the sanitation space, and I still do, the food space for a while. And so, I try to kind of identify those control points in those systems, especially, and I try and do it through the kind of the lens of the communities I get to work with. But the one that kind of unifies a lot of these is the gut. Everyone has a gut microbiome, and so that's what made that one really interesting to kind of focus on. And so I think, if we can think more about appreciating those leverage points, those control points, we can really kind of think about how to scale effective solutions more broadly, not only in the malnutrition space, but water, sanitation, food, all those kind of core needs that undergird our society.
That's so cool, Lee. That's all I had for you. Thank you so much for coming on the show.
Oh, thanks for having me. This is great.
Taking us on your decidedly non-linear but very, very interesting path. This has been a lot of fun, and I hope
the culmination of my career is this interview. So that's why.
A lot of pressure. Oh man, this better be a good episode.
Knocked it out of the park. So
all right.
Thank you so much for having me.
Thanks for coming on the show. We love it. All right.
Brilliant.
Thank you for tuning into Lab Coat Optional. We are a production of the Strategic Marketing Communications team at Arizona State University's Knowledge Enterprise. Knowledge Enterprise is led by Executive Vice President Sally C. Morton. If you enjoyed the show, leave us a review on the podcast app of your choice. And if you found us on YouTube, please like and subscribe. We are at the mercy of the mighty, fickle algorithms, and stuff like that helps people find the show. As always, lab coats are optional on this show, but we want to keep our researchers safe in the lab. So wear your PPE. Until next time, stay curious.